model is of Aditya L1. So Aditya L1 was launched on September 2nd, 2023.
Hits this antenna over here. This antenna then travels, then sends the EM wave into this box. Are very non-hypergonic. They can be used to start the ignition by using mono oxides of nitrogen, and the fuel that we use is mono. Advanced of the sounding rocket. So this is the booster part and this is the sustaining part. So booster part is filled with solid propellant.
നാലാഞ്ചിറ സർവോദയ സെൻട്രൽ വിദ്യാലയത്തിൽ ഉന്നത് അഭിയാൻ, സർവോദയ സെൻട്രൽ വിദ്യാലയ, അനന്തപുരി ഫൗണ്ടേഷൻ എന്നിവയുടെ ആഭിമുഖ്യത്തിൽ സ്പേസ് എക്സിബിഷൻ, സ്പേസ് കിസ്, സ്പേസ് കാർട്ടൂൺ വർക്ക്ഷോപ്പ് തുടങ്ങിയ വിവിധ പരിപാടികൾ സംഘടിപ്പിച്ചു. ഇന്ത്യയുടെ ബഹിരാകാശ പദ്ധതികളെ പറ്റിയുള്ള അറിവ് കുട്ടികളിൽ കൂടുതലായി എത്തിക്കുക, യുവതലമുറയെ ബഹിരാകാശ മേഖലകളിലേക്ക് ആകർഷിക്കുക തുടങ്ങിയവയാണ് പരിപാടിയുടെ ലക്ഷ്യം. പ്രദർശനത്തിൽ റോക്കറ്റ്, സാറ്റലൈറ്റ് തുടങ്ങിയവയെക്കുറിച്ചുള്ള വിവരങ്ങൾ വിദ്യാർത്ഥികൾ തന്നെയാണ് മറ്റുള്ള വിദ്യാർത്ഥികൾക്ക് പകർന്നു നൽകിയത്. ഇതിനായി സ്കൂളിലെ തിരഞ്ഞെടുത്ത കുട്ടികൾക്ക് പ്രത്യേക പരിശീലനവും നൽകിയിരുന്നു.
So good morning. Today we'll be looking into sounding rockets and launching vehicles. Launch vehicles and sounding rockets. So sounding rockets are sent to the atmosphere to know their conditions, atmospheric conditions. So this is Rohini, that is RH-75, that is the first sounding rocket. So 75 is the diameter of this rocket, that is 75 millimeter. And now we come to advanced of the sounding rocket. So this is the booster part and this is the sustaining part. So booster part is filled with solid propellant. Okay, solid propellant is fueled with oxidizer, and this is the sustaining part. The sustaining part consists of payloads. The payloads has copper shaft. Copper shaft is released in the atmosphere to get the signals. Now we see launching vehicles. Launching vehicles are the things, are the rockets that take satellites to the space. Okay, so this is SLV, that is satellite launching vehicle, and the satellite launching vehicle can have a capacity of 40 kg of the satellites can be taken to the space. Okay, they have no step-ons and they are of 4 stages, and they also have solid propellant. Solid propellant is actually harmful for the atmosphere, and also it is used because it can be compressed. Okay, and then the solid propellant, it is made up of aluminum powder and ammonium perchloride. Yeah, so rest, and these does not have step-ons. Step-ons are the side. You can see in the later on you can see small stuffs placed at the base. Okay, so this doesn't have that because only 40 kg of the satellite is taken to the space. So that's it. So this is our engine PS4. It is used in the 4th stage of PSLV, and the speciality of this is that this body is made up of carbon, and this works under the 3rd law of Newton, that is every action has opposite and equal reaction, and this is an oxidizer as well as fuel. The oxidizer that we use here is mono oxides of nitrogen, and the fuel that we use is mono methyl hydrazine. So these two will combust when it reaches the space, and this can lift up the PSLV. And this is Vikas engine. It is named after our father of Indian space program, that is Vikram Sarabhai. And here also we have the same thing. This is the oxidizer and this is the fuel. And here the fuel is unsymmetrical dimethyl hydrazine, and the oxidizer is nitrogen tetraoxide. Then this is just a prototype of this. The real thing is 10 times bigger. Both of this is 10 times bigger than this. That is, one PSLV is almost 16 feet, almost more higher than this building, and this is used in the 2nd stage of PSLV.
So this model is of Aditya L1. So Aditya L1 was launched on September 2023, and the main objective of this model or this mission or this satellite is to learn more about the corona of the sun. So the corona is the outermost layer of the sun. So this mission, this observatory has been launched to point L1. L1 means Lagrange 1. L1 stands for Lagrange 1. So in this, the most important thing or the speciality of this point is that the gravitational force of Earth and the Sun gets nullified at that point, and it makes it easier to capture clear-cut images, so that the clear-cut images, since there would be no eclipse at that particular point. So then it also helps us to know about the period of existence of Earth and Sun. And another use is that, as we know, the radius of the Sun increases over time, and it finally leads to the gulping of all other planets. And this observatory helps us to know more about the reactions which would potentially lead to that increase in diameter. And it also helps us to learn more about the reactions which lead to global warming and things like that. So, and in conclusion, we can say that this thing has covered only 1% of the total Earth's and distance, and that shows we still have a long way to go.
ഇത് ഗഗൻയാനാണ് നമ്മൾ യൂസ് ചെയ്യുന്നത്. ഗഗൻയാൻ മിഷനാണ് ഇത്. ശരിക്കും പറഞ്ഞാൽ പീപ്പിൾസിന്, അതായത് ഹ്യൂമൻസിനെ നമ്മൾ സ്പേസിൽ കൊണ്ടുപോകാൻ യൂസേഴ്സ് ആണ്. ഈ ഒരു ഭാഗത്തിന് പറയുന്ന പേരാണ് ക്രൂ മോഡ്യൂൾ. ഇത് സർവീസ് മോഡ്യൂൾ. ഇതാണ് പ്രൊപ്പലൻ്റ് എനർജി കൊടുക്കുന്നത് നമുക്ക് സ്പേസിൽ പോകാനുള്ള ഫ്യൂവൽ എല്ലാം. ഈ സാധനം മെയിൻലി നമ്മൾ ആൾക്കാരെ കൊണ്ടുപോകാൻ യൂസ് ചെയ്യുന്നതായതുകൊണ്ട് ഇതിനായിട്ടുള്ള സർവൈവൽ കിറ്റ് എല്ലാം ഇതിനകത്ത് തന്നെ പ്രൊവൈഡ് ചെയ്യുന്നുണ്ട്. എന്തെങ്കിലും എമർജൻസി ലാൻഡിങ് സമയത്തൊക്കെ നമുക്ക് ആൾക്കാർക്ക് രക്ഷപ്പെടാനും ഫുഡ് ഐറ്റംസ്, വെപ്പൻസ്, അങ്ങനത്തെ എല്ലാ സാധനങ്ങളും. ഇത് ഒരു പർട്ടിക്കുലർ പോയിന്റ് ആകുമ്പോൾ ഈ സർവീസ് മോഡ്യൂൾ മൊത്തത്തിലായിട്ട് ഇതാവും, റിമൂവ് ആയിപ്പോയി. ഇത് പിന്നെ തല തിരിഞ്ഞ് ഓപ്പോസിറ്റ് രീതിയിലാണ് വന്ന് ലാൻഡ് ചെയ്യുന്നത്. ഈ ഭാഗമാണ് വന്ന് ലാൻഡ് ചെയ്യുന്നത്. മെയിൻലി ഇത് ശരിക്കും ഒരു ഓഷ്യനിലോ അല്ലെങ്കിൽ ഫോറസ്റ്റ് ഏരിയ അവിടെ എവിടെയെങ്കിലാക്കി ലാൻഡ് ചെയ്യും. അപ്പോൾ സർവൈവലിന് വേണ്ടിയുള്ള എല്ലാ സാധനങ്ങളും ഇതിനകത്ത് തന്നെ പ്രൊവൈഡ് ചെയ്യും.
So this here is a communication satellite. This is used for internet, phones, PCs, etc. How this works is basically when we send a message, an EM wave from our phone hits this antenna over here. This antenna then sends the EM wave into this box, where it is then decoded and sent through this antenna. The EM wave from this antenna will be sent to the receiver. Now this satellite orbits at a radius of 36,000 kilometers from the Earth, and at the back there's a structure called LAMP, which is called liquid apogee motor, and it helps the satellite withstand the very high velocity and temperature at which it travels in space.
So this is the research capsule recovery experiment. This was actually done in 2007. This experiment was done to make sure we could bring back objects safely from space, because while objects come back from space, there is a lot of air friction that it has to go through. So we need to make sure that these objects can withstand such high temperatures. So as you can see, it is made up of silica tiles with carbon layer, which can withstand up to like 2000 degrees Celsius. Now this experiment was done in 2007. This was sent to orbit, and then after 12 days we successfully landed this back in Bay of Bengal, making this could pave its way for future experiments where we need to bring back objects safely from space. This is one of the major components of reusable launch vehicles. It's a basis for that.
So when we talk about satellites, there are mainly two classifications. One is remote sensing satellites or Earth orbiting satellites, and the other one is a communication satellite. So when we talk about remote sensing satellites, these are satellites that study the Earth from a particular distance. One major type is the OceanSat, that is used to study the oceans for locating schools of fish, different classes of algae, etc. And these remote sensing satellites, what they do is they are fitted with high resolution cameras which can capture these images, send them as radio waves to the ground stations, which are then re-accessed using computers and electronic devices to reconvert it back to picture form. So these have been extensively used by our governments to study the agricultural patterns, water currents, and predict weather, with a lot of other applications in disaster management as well.
Okay, so this is cryogenic engine, and we know that this engine uses hydrogen and oxygen as its propellant. Hydrogen is the fuel and oxygen itself is the oxidizer. So this hydrogen is colorless and odorless gas, so we liquefy it. We liquefy hydrogen by reducing its temperature to minus 250 degrees Celsius, and we know that as the combustibles are very non-hypergolic, they can be used to start the ignition by using a spark system. So this two combustibles are eco-friendly in nature. So this the cryogenic engine can be used for higher mileage as well as for creating environment-friendly propellant systems also. Aryabhatta. This is India's first artificial satellite. Although it is made by India, it was launched by the USSR. This satellite is about 360 kilogram, and this was the first satellite which was launched by India. This was launched on April 19, 1975. ASLV, Augmented Satellite Launch Vehicle. It consists of 5 stages, 1, 2, 3, 4, and this is the 5th stage, and this is known as heat shield. Inside this satellite is being kept and it is been protected, and this is strap-ons. Here we can understand that there is no strap-ons here, whereas it has, because here the weight of the strap-ons is 150 kg. There is a change in weight. So for protecting the satellite we use strap-ons, and it is also 23.5 millimeter. This is PSLV, Polar Satellite Launch Vehicle. What is the need of PSLV? From the word we understand that Polar Satellite Launch Vehicle means it always focuses towards the polar, and it is being used in Chandrayaan-1 mission. And it consists of 4 stages: liquid propellant, solid propellant, liquid propellant, solid propellant. It has strap-ons. There you can see there are 2 strap-ons, whereas it contains more strap-ons because the weight inside is 150 kg. So for carrying that there are more strap-ons. And when it comes to the it is GSLV, that is Geosynchronous Launch Vehicle, and here it consists of 3 stages: cryogenic stage, liquid stage, and solid stage. It consists of 4 strap-ons, and here is the place where satellite being kept. And for protecting the satellite, this cryogenic stage is being given. Cryogenic stage means it is helping cooling the satellite. That is the satellite being cooled. It has the chance for getting burnt. So for protecting the satellite from cooling, we use cryogenic stage. And it is around 49 meter, and it is around 44 meter. And this has been used in many functions, where this is being used in Chandrayaan-1.
Single-use rockets. That means that once we send them to space, even if the mission is a success or a failure, we can't use it again. So it's really, economically not feasible. So we developed this, which is a reusable RLVTD, reusable launch vehicle, this is not single-use. We can use it again and again after doing some testing. So we send this to space, and the body is made of very high temperature withstanding material. It's actually coated with silica on the bottom, and this part is known as the nose cone. It's made of a carbon-carbon alloy which can withstand temperatures up to 2000 degrees Celsius. As I already said, it is in the testing phase. We actually conducted a test in Chitradurga, Karnataka airport, where we used a Chinook. This helicopter is called a Chinook. We used it to lift it up and send it around 5 kilometers up in the air, and then we released it and we tested the landing. Countries like Colombia, they have already started using this, but India, since it is a developing nation, we are a little bit behind, but we are actually the experiments which we are conducting are going great, and soon we hope to use it commercially as well. We can use it to send crew and materials into space, and then we can just bring it back and reuse it again and again.
And how do you overcome it? Because we are talking about overcoming it, right? Yeah? We are talking about a technology that overcomes it. How do you overcome stress and strain that you have in your studies?
Stress and strain with our studies is something that we have learned to go along with. This is part of our studies right now. So we have learned to grow accustomed to it, and we have found ways to relieve such stress productively.
And father has safely back to earth. We have silica tiles and carbon-carbon layer which can withstand up to 2000 degrees Celsius. And this was actually done in 2007. We successfully had this in orbit for 12 days, and we brought it back to Bay of Bengal.
So the other uses of this observatory is that as we know, the diameter of the sun increases gradually, and it finally leads to the gulping of all other planets, and this mission helps us to know more about the reactions of the corona, which leads to the increase in its diameter, and also about the reactions which lead to global warming.